Swayam Prabha. Digital India. Educated India.
Good morning again to our course on Introduction to Mechanical Micromachining. Today we are going to learn our last topic, that is related to sensors and metrology for micromachining operations. We have seen till now lot of different operations, and we have seen there are different components also in the machine tool, but ultimately everything comes down to the measurement system, because once you do machining at a micro scale, our objective is that how to track down all the movement of the cutting tool, that is at the micro scale, and once the machining is over, we have to also do some type of measurement, that whether the part is exactly as per the dimension or not. So, we are dealing with 2 or 3 different type of systems. One is the related to the cutting tool, because our objective is to monitor the cutting tool throughout the machining operation, and at the end we have to also see that whether there is still any life available in the cutting tool or not, so that we can either use it for the next operation or we can discard it. Another thing is the workpiece, because once the machining is over, our objective is to measure the dimensions, that is if possible on the machine itself, because if you remove that component, again you have to mount at the same location, and that creates lot of problem. And third one is the machine tool itself, because we know that there are lot of different components on the machine tool, those are connected with each other, and if any there are problems, and that problems will actually replicated or it will be reflected onto the component or the cutting tool. So, we have to put some sensors for monitoring the health condition of the machine tool, then monitoring of the cutting tool and workpiece also, and after that we have to use some metrology, something like that cameras or microscopes or some type of other techniques by which you can measure the dimensions and do some type of characterization of the cutting tool and the workpiece. So, let us see that what things we are discussing in the this new topic. So, now this is the metrology requirement. Now, if you see, we are starting with some material. Now, you have a blank, that blank is actually fabricated or the made by sintering process, forming process or the casting process, and every stage you need a metrology, because first you see the metrology required for material. So, here what you do, that you see that what are the composition of the material, and then you have to monitor this particular process, so that there should not be any type of deviation in the composition of the material, and that composition will be strictly monitored or strictly maintained during that manufacturing process. So, monitoring is metrology required here also. And once you have a blank or the rough component, then what you do, that you use a machine tool, then you do some type of cutting operation, abrasive process or chemical process, by which you do some type of machining operation, and after machining operation you do some heat treatment also if you want to improve the surface properties of the different components. So, here also you need a metrology, and once this thing over, then by chance you are making some small component, then you need assembly also. So, during assembly also you need a metrology. So, because you have to make sure that all the parts are aligned according to their required dimension and required locations, and once this thing over, then you have to inspect the complete assembly, that there should not be any type of loose component or the any type of unwanted movement between the two different joint components. So, here also you need a inspection, and finally the product. So, you can see here, this is a routine things, it is not actually specifically used for the micro machining, but this is the complete sequence of the product, starting from the raw material to the final product, and metrology is required at each and every stage. So, you can understand that how, what is the importance of this metrology to make sure that final product is as per your desired dimension and the desired properties. So, how do you monitor and control the machining process? Now, what is the first thing? The process controller plays important role, where you have to put the process references. Process references means what is your tolerance level, and what are the different type of properties are required onto the machining part, that is how many components are required. So, those things actually fed to the controller, and once controller get all this information, then what is the reference process variables are available. So, these reference process variables are mostly the servo command. So, this is related to the speed, feed and depth of cut, right. So, you have to set this parameter, other than that you have to provide coolant and all the parameters. So, once you give this command to the servo controller, so servo controller are the x, y and z motion. So, right now let us restrict ourselves to the 3 axis machining center only. So, once you give a servo command, then what happens that it will drive all the 3 axes to do a machining operation. So, this is called the actual process variable. So, here what you are getting, here you are getting a force signal, then acoustic emission sensor signal, and there are many sensors, whatever sensor you are using for monitoring of this particular manufacturing process. So, once you do actual machining, what happens, these particular sensors will get some data. So, those data are raw signal. Raw signal, that means it will get all the data, whether you require those data at the later stage or not. It is a actual mixture of all the required data as well as unwanted data. Then what you have to do, you have to filter. So, here what is that filter part? That if filter, what happens, that you are actually removing the unwanted data, or you are actually extracting required signal or data, right. So, that is by which you can do filtering. So, you are actually now extracting only those things which is important to you, and then filtered sensor data will go to the monitoring system. So, now here what you are doing, that you are actually monitoring those things, and then based on this monitoring system, now suppose you are using a force signal, right. So, you are doing a force signal, and now force signal is always in the time domain, and this is the force. Now, let us see, it is a cutting force, right. So, initially it is starting from here, and then you are doing turning operations, it will maintain this particular thing, and later on what happens, that you will find that it suddenly goes down in this case. So, what is this particular thing, that this particular thing will tell you the tool is broken, correct, because now you are not getting any contact between the cutting tool and the workpiece. So, it is going down. So, here those things are you are monitoring. Now, if you tell the system that if your force is going below a certain level, so this is you consider a threshold value. Now, suppose it is a closed loop kind of thing, then what you can tell, that you provide one program in such a way that, and tell that program that if the force is reducing below this particular threshold value, then stop machining. So, in that case what you can do, actually you can actually reduce the unwanted time here, because if you do not give this thing, your machining will still continue, but there is no contact between the cutting tool and workpiece, and all the thing will be wastage at the later stage. So, here once you get those data, this is one of the ways of doing that thing, or an operator will actually look into this monitoring system or the whatever data you are collecting, and then according to that it will actually again set this process controller. So, what you are doing, that you are again refining the speed, feed and depth of cut and other parameters in such a way that you can actually increase this particular efficiency of this particular machine tool. By that way you can actually continuously monitor this system, and you make sure that there is no any type of problem during the machining. So, by that way you can control the machining process by monitoring the signal coming out of the different type of sensors, right. So, what are the different type of controls? Now, there are 3 different type of controls. If you see from the machine, so let us start with the machine. So, how machine will behave. So, machine objective of machine is to give the x, y and z motion. So, what we do with the machine, that we actually move the 3 different axes. X, y is mostly related to the workpiece, and z is mostly related to the tool, right. So, by moving these all 3 axes you do a cutting operation. So, when you do movement at that time these 2 things will come into picture. So, that is the position and the velocity. So, what is the initial position and where you are going, that is the one thing, and how fast you are going. So, those things are related to the position and velocity. So, that is done by the servo control. So, once the machining part is over, then it is operating this x and y direction and or z direction, then what it is going to do, that it is removing the material. That means, it is physically touching the component and then it is removing the material. So, when it is removing the material, what things comes into picture, that is the force and the tool wear, right. So, that is related to the processes. So, now that is called the process control. And once everything is over, that you have moved the component and the tool in xyz direction, you have performed a cutting operation, and now finally you have a product. So, once the product you have, then what happens, the supervisory control comes into action, that it will measure the dimensions and it will see the what are the surface characteristics, and then it will decide that whether this is acceptable or not. So, these are the 3 different controls. So, now you can see here that you need sensors at all the 3 locations. Now, supervisory control, if you want automated automatic performance of this thing, then what you do, you have to add some type of microscope with a robotic arm. So, wherever component is machined here, the robotic arm actually directly goes to the machine and then do the measurement, or you remove this product out of the machine and then there is a separate table or the separate station available for inspection, where you do all different type of inspection related to dimension and the surface topography. So, here you need 3 different controllers for complete monitoring and the control of a manufacturing process, and we will see that what are the different controls to be performed at a different locations. Now, basic component of the sensor. So, now you can see that these are the difference of words. First is our object. Object means our machining process. Let us consider this is a machining process. Now, we have attached some sensor to the machining process. Now, sensors are getting or a lot of data, that is raw data, including everything whatever you are giving the signal in terms of force signal or current signal, voltage signal, whatever way. Then there is a transform or the conversion, because most of the sensor will give a voltage as a output. Right, but our objective is not the voltage, because finally whatever you are using the dynamometer for force sensing, our objective is to get a force reading, not the voltage reading. So, it will do all the transformation, that means conversion from the voltage to the force reading, or some type of current reading to force reading, or there are different other sensors available which will do conversion from a electrical signal to the mechanical signal, or mechanical signal to the electrical signal, and then conversion is required to make sure that you are getting the required result in terms of your own variable, not in terms of the voltage. So, once you get the result conversion, then still it is in the raw data, because whatever voltage raw data was there, same raw data you will get the in terms of force. So, now you need a signal processing. So, now you have to process that signal, whatever signal you are getting from this sensor, that signal processing is required here, that what is required out of that, whether you need a average value, you need a highest value, lowest value, or what other things are required. Now, suppose consider this is the force signal, cutting force signal, and what happened that you are getting some type of signal like this, right, and this is the second. Now, you want to see that how many times it has crossed this particular value. So, it is showing 1 time, 2 time, 3 time, 4 time. So, these are the different techniques by which you can actually do some type of post processing onto the signal. So, that is called the signal processing. You want a peak only, or you want a average value of these signals. You want to say that how all the values are falling in which particular range of this force signal, that also you can do measurement in terms of different type of post processing operations. So, that is called the signal processing. So, once signal processing is over, that means now you have a required data, whatever your intended data, or where you want to do some type of analysis, or you want to do some judgment, those things are available. So, now next step is the decision making, right. So, now decision making, sometimes whatever it comes under the sensing system, because you have given one type of rule base, that suppose your force reading is more than this particular value, then stop machining or do some type of other correction into the object, that means in terms of speed, feed and depth of cut. You change the RPM or you change the feed rate. By that way you can do lot of fully automated monitoring or the control of the manufacturing process. So, now once you get this signal, now you have to do a decision making, that what to do now. So, now there are two ways, that one, if it is a semi automatic, that means operator comes into action, that means from whatever graphs are there here, the operator will read those graphs and then operator will decide that what is the next step. If it is a fully automatic or a closed loop, then what happens, that those decision making is done by the machine controller, that you have a set rule base, that if this thing happens then change the RPM, if this thing happens then change the feed rate, then machine controller itself will take the decision and operator will not play any role in that case, right. So, in that way you can actually get the things done, and signal processing can directly go to the operator also, you do not require any decision making in between these two. Decision making is required when you are using a machine controller. So, by signal processing you can get the things done, that by decision making you can get the operator will take the decision, or from the signal processing itself operator will take the decision that what should be done in the machining operation or during the process. So, this particular thing is the sensor system. So, this thing is common for almost all the sensors, by which you can get the raw data, then you have to transfer and conversion, then you have to signal processes, processing need to be done, and then you take the decision. Right. So, what are the specifications? Now, when you want to buy some sensor, at that time you have to specify those sensors, that what are the requirements of those sensors during a operation. So, now first thing is the sensitivity. Sensitivity means suppose you are giving one input, whether your sensor is sensing that input or not, right. So, with a given input, what is the output from the sensor? So, that is called the sensitivity. Resolution, we have seen already that what is the smallest measurement it can perform. Accuracy, that means how far it is close to the dimension, or how far close to the desired location. Linearity, that means if you want to plot something with respect to your linear function, then this is called the linearity, then how much it is matching with the linear fitting of the curve. Hysteresis is very important, because sometimes what happens, your input graph and output graphs are different. Suppose now this is your, suppose it is going into the highest location, and then when it is returning, at that time it is not returning to the original position. So, now you can see this is your input location, at input location you are getting a two output, at one location here and one location here. So, this is the ongoing and this is coming back, right. So, this is something which is actually the what we can say, that this is a reminence value, that means this much should not be there, it should come directly to the 0 value. So, this is called the hysteresis loop, that means what going means signaling when it is responding, at that time it is going to one particular path, and when it is returning back to its original position, it is actually taking another path. So, at that time you are end up with the hysteresis, where you will get the two input output value with respect to one input value. So, those things should be reduced as much as possible. Drift is actually something which create problem with respect to the aging of the component, because we know that if you buy a new system today, it will perform better, but after 1 year or 2 years you will get some type of problem. So, that is related to the drift. Full scale output. So, this is the full scale output. What it is showing, that you start with the minimum possible value, whatever is the sensitivity value, and then go with the highest value, and then analyze that what you are getting out of the particular full scale output signal. Right. What is the measuring range? That is very important here, because we know here in micro machining that our most of the forces are very small, right. So, suppose you want to measure some force here, suppose this is starting from range here, it is considered that starting from 0 to you want to measure only 10 Newton, right. So, now you consider that your all the force measurement, everything comes within the 10 Newton, then you can actually increase the sensitivity to a very high value. But if your measurement value is from 0 to the 1000 Newton, then your sensitivity will be less, because now you have to make your system in such a way that actually it can measure the 1000 Newton. So, for measuring 1000 Newton, if you make system very sensitive, then what happens that sometimes you are end up with the garbage values. So, those values are not important to you, and that is why when you are looking with a very small range at a lower scale, then you can get a high sensitivity here, but that is not the case here. Here you have to sacrifice with the sensitivity, because that is the same sensitivity cannot be achieved when you are looking with a very long range. So, you have to part out something like that, then you can go with the 10 to 100 Newton or 0 to 50 Newton or something like that. In that different range, you can actually set the different parameters. So, these particular parameters are actually connected with the what is the range on which you are working. So, smaller the range, higher the sensitivity resolution you can get it, because we have seen in the linear motors and everything where your stroke of length is very small. If the stroke of length is small, then only you can get the result sensitivity, resolution and accuracy at very high, that is at a sub nanometer level. But when you are talking at a millimeter scale, those things you have to sacrifice at the later stage. Right? Then offset is important, because it is that from which location it is starting the measurements. So, those offsets should be accountable when you do final calculation of the actual forces. Response speed, that means once you give a signal, after how much microsecond or millisecond your sensor is responding to that particular stimulus. So, that is important. Faster the response speed, faster is the sensitivity. That means your that directly responsible with respect to the data acquisition system, that what type of systems you are using for capturing all those signals. Crosstalk, that means mixing of two different signals, right. Suppose you are doing machining. Now, suppose you are doing a machining with a end mill cutter and you are cutting a slot, right. Your end mill cutter is here and it is rotating, and then you are moving in this direction, correct. So, you are getting two signal, one signal is for the feed rate, and that is one signal is here, and there is one signal here, that is one is the normal force and another is the tangential force. Now, things is that these two signals should be separated, that means it should not mix with each other. Sometimes what happens that if your measurement location, that means sensor which you are using, whether it is a strain gauge based type of dynamometer or piezoelectric based dynamometer, if these signals are actually mixing with each other, then what happens, you will not able to capture the real condition of the cutting forces. So, crosstalk should be minimum as much as possible, so that you can get the independent output without mixing of two signals. Overload characteristic, because sometimes what happens that your system is actually rated for a one particular input only. That means, suppose your dynamometer is rated for 100 Newton only, and you are giving a 110 Newton of force. So, whether your dynamometer will perform some operation or it will break down completely without giving any type of signal. So, that is called the overload characteristics, but up to what overload it can operate within a safe zone. Operating life, that is important, because that will directly related to drift also, that in a different environment how much life you can extract from a sensor, because everything is a finite life, you cannot use the same sensor for lifelong. So, all these different parameters will tell you that which particular sensor is useful for your operation. But when you talk about micro machining, what our important things are sensitivity, resolution, accuracies are very important, and these three parameters many times what happens, it will decide rest of these parameters, because if you set this parameter very high, then your measurement range will be very small, you cannot measure for a very large variation. And the output format, what is the output format, that is also important, because ultimately what we need everything on the computer screen, right. Rest of the things, whatever from raw data to the conversion, then conversion to the signal processing, everything is done by a computer control program, by which these particular softwares or the sensors are completely matched with a particular environment. So, our objective is to find a particular graph. Suppose you are measuring a force with respect to time, then we need force respect to time only, we do not require voltage with respect to time. So, what our output is coming, that will decide that whether it is exactly what we required, that is the output, or we have to further refine or further convert that output into the other required output. So, that will also be one of the specification of the sensor. And the ambient operating conditions. Now, we know that in machining what we do, that we use a coolant also, then there are chips coming out of it, and those chips are very hot also. So, again we have to find out what are the sensors which are completely ineffective in this type of environment. So, they will not create any problem when you operate, when you install those sensors into this type of environment where the coolant is available and there is high heat zone available, and sometimes forces are also exerted in terms of vibration. So, we have to make sure that what are the sensors which are suitable for those type of environment, and then only select these different parameters, so that you do not actually end up with some type of wrong signal or the wrong output. And what are the sensors? This slide we have seen long time before, but still this slide is relevant to this particular topic, because this slide is telling you that what are the different type of sensors you can use for monitoring and control of a manufacturing process. Now, it is a vertical milling machine. Now, you can see here that there are different, we have already discussed. So, I am not going to discuss those sensors again, but you can see that it is starting from monitoring the machine tool, then monitoring the machining operation and monitoring the workpiece condition, and also the coolant and everything, and climate also it can monitor throughout the surface. So, by this way you can understand that how this particular machine tool sensors are useful, but you also know that all sensors are not required. That again depends on the what is your requirement, depending on you select the sensor which are more suitable for your application. Now, coming to the different type of measurement approach, one is the direct measurement approach. What is the direct measurement approach? That you do machining and measure the required quantity directly there itself. You do not want any conversion between the two different values. So, that is the measurement of actual quantity. Now, suppose you want to measure the surface roughness here, then you do not want to convert that force signal into the surface roughness and then you find out some empirical formula. You directly put one camera here and then capture the images. Right. So, based on that you can get the surface machine surface image, and then you decide, or then you do some type of decision making whether it is correct or not. Right. So, tool we are using camera for visual inspection, laser beam etc. for the placement accuracy and everything. So, these are called the direct approach, because you are measuring directly what is your intention. But what is the problem? That many direct methods can only be used as a laboratory technique, because here what happens, that if you put many things here and there, then machining operation actually you cannot perform in a much better way, because these things will occupy many spaces and you do not have liberty to set the workpiece and then again do the setting of these parameters. Right? So, there are advantages of this, the high degree of accuracy, because now you are measuring what you require directly, there is no conversion between the two different values, and used extensively in research to support the investigation of fundamental and measurable phenomena. Because initial stage when you want to do some type of fundamental research, you do not want any type of inaccuracy in the measurement, right. Later on you can actually move to the some other part, but right now what you need, you do not require any type of noises in between the measurement and the signal what you are getting. So, this is what very advantageous in this thing, but practical limitations are there, because these things are mostly at the laboratory or not at the production level. So, excess problems during the machining, illumination and cutting fluids, there are many things are there which makes this particular direct approach very inefficient in handling the actual or practical situations. So, we do go with the indirect approach. What is the indirect approach? That you do measurement of current, power, speed and position, and based on those things you do somehow you calculate the condition of the cutting tool, workpiece or the some other component of the machine tool. So, it is indirect means you are measuring some auxiliary quantity, and then auxiliary quantity once you measure, then you correlate those auxiliary quantity with respect to the actual parameter. So, suppose you consider cutting force component, right. So, cutting force component has nothing to do with the machining, right. So, it is just measuring the what are the forces acting between the cutting tool and the workpiece. But by getting those signal, you are getting many useful information related to the cutting tool, workpiece and the situation of the different type of alignment problems. So, actual quantity is subsequently deduced via empirical determined correlations. So, here what we are doing, you measure the cutting force, and by changing the two different parameters, suppose you are changing the speed you are changing, and then changing the feed rate. By changing these parameters, you are changing these things, suppose 1000 rpm to the 5000 rpm, one at a time, and then you are changing feed rate with a 2 mm per minute to 5 m per minute. So, you select this parameter and then you do changes 2, 3, 4, 5 like that, and every time you get one force signal, and then you create a one type of empirical formula that if you do operate this particular feed, speed and depth of cut, then these are the force reading, and based on that, after that you do measurement of a stator or the cut tool wear and all these thing, and then you again find out the how forces are related to the cutting tool wear and how the forces are related with respect to the alignment of the workpiece, whether it is a cutting in a straight line or it is cutting in a taper turning kind of thing, then every time you will get a different reading. So, by that way you have to measure in a indirect way, right. So, it is less complex and more suitable for practical application. That is the reason the dynamometers are most widely used compared to those type of direct approach where you put a camera and do some measurement, and it is a less accurate than the direct measurement. But problems are also there because ultimately everything comes under the empirical formulas, that how what are the fitting of this formula with respect to the cutting force measurement. Now, you consider that suppose you have some type of data here, suppose these are the random data, and then what you have to do, you have to do a fitting of one curve here, and that curve will tell you that how far it is fitting. If it is a polynomial curve, then probably it will pass through this all the points depending on the what is the power of that. If it is a straight line, then some of the points will be missed and you are not getting the exact value. So, these are the two different approaches by which you can do measurement of the different type of signals. So, let me finish this class here. We will continue this lecture in the next class. Thank you very much.